Good morning to all. This is Paveethrun, 14MCD1051. Here I am going to present a PPT on polymerization technique. Here my PPT consists of introduction to polymers and some chemistry behind the polymers and polymerization technique. And also I am going to discuss about the merits and demerits of each and every technique. If we start with a short introduction about the polymer. A polymer is a very large molecule in which one or two small units are repeated over and over again. The small repeating units are known as the monomers. Like imagine that the monomer can be represented by a letter A, then a polymer made of the monomer would have the structure like AA as shown here. In another kind of polymer, two different monomers might be involved. If the letter A and B represented those monomers, then the polymer could be represented as AB as shown there. A polymer with two different monomers is known as the copolymers. Some chemistry behind the polymers are like polymers are organic and chain molecules. They can vary from few hundred to thousands of atoms long. There are three classes of polymers that we will consider like thermoplastic, thermosetting and electromatic. We move on with the polymerization techniques. Actually, there are four commonly used methods of free radical polymerizations like bulk polymerization, solution polymerization, suspension polymerization and emulsion polymerization. Bulk polymerization is one in the procedure used to induce radical polymerization with a vinyl group monomer. It is carried out by adding only vinyl monomer with the solvent usage of a small amount of initiator. It is a type of polymerized by heating. Once the reaction starts, the heating is stopped and reaction is exothermic. The heat generated is dissipated by circulating water jacket. Viscosity increases dramatically during conversion. Agitator is used to stir and reactor chamber is used for this entire process. Heating and cooling jackets are used to control the temperature and monomer plus initiator are used to form the polymer like polystyrene, polyvinyl chloride and low density polyethylene. The feature of bulk polymerization is that the only polymerization rate is high and relatively few polymer is obtained with this process As the removal of heat of polymerization is difficult, it is hard to adjust the temperature with selective heating. In addition, post-processing is complicated, for example generating polymer because solidified and it is attached to the container. And these are the advantages and disadvantages of this bulk polymerization technique. Advantages are like the system is simple and requires thermal insulation. The polymer is obtained pure. Molecular weight distribution can be easily changed with the use of chain transfer agent. Disadvantages of this process is like heat transfer and mixing became difficult as the viscosity of the reaction mass increases. Highly exothermic. The polymerization is obtained with a both molecular weight distribution due to the high viscosity and lack of good heat transfer. Very low molecular weight are obtained. The second polymerization technique is called solution polymerization technique, in which some disadvantages of the previously seen bulk polymerization are eliminated in the solution polymerization technique. Monomer along with the initiator dissolved in solvent form polymer stays dissolved. The mixture is kept in polymerization temperature and continuously agitated. Depending on the concentration of the monomer, the velocity of the solution does not increases. It is the one of procedure used to induce radical polymer with a vinyl group monomer. It is the type of polymerized by heating and using monomer and initiator. Benzyl peroxide soluble in monomers or solvents are used for initiator. The feature of the solution polymerization is that the polymerization degree and rate is reduced compared with the previously seen bulk polymerization technique, as the heat released by the action is absorbed by the solvent. So it is easy to adjust the temperature. The solution polymerization is quite useful for the use of polymer fluid, as it is after polymerization but need to remove solvent and collect polymer to take polymer as in solid form. In this procedure, PVC, PMMA can be and also with polyvinyl alcohol can be produced by this process. And these are the advantages of this solution polymerization technique. The solvent acts as a diluent and helps in facilitating continuous transfer of heat of polymerization. Therefore, temperature control is easy. The solvent also easy stirring as it decreases the viscosity of reaction mixture. Solvent also facilitates to the easy of removal of polymer from a reactor. Viscosity buildup is negligible. The main disadvantages of this process is the method is costly since it is used to costly solvents, and the techniques gives a smaller yield of polymer per reactor volume. The purity of the product is also not as high as the previously seen bulk polymerization technique. Removal of large spectrum solvent is difficult. The third thing is suspension polymerization. It will overcome the disadvantages of the previously seen solution polymerization. The solution polymerization technique is cost high due to the using of costly solvents, whereas in suspension polymerization it uses water as a solvent instead of solvent. Liquid is dissolved monomers suspended in liquid phase, liquid like water. Initiator used are monomer soluble, and suspension polymerization is a process in which an insoluble monomer is dissipated and suspended by continuous strong agitation in liquid phase, where liquid phase will be usually water, and it becomes a monomer droplet with a size of 0.01 to 1 millimeter. In addition to the polymerization, in which soluble initiator is added to the monomer. Polyaddition reactions such as the polyurethane may also performed in the suspended form. Actually, the polymerization advanced in the droplet of the monomer and practice polymer is obtained. Spherical particles are obtained by performing suspension polymerization with the use of vinyl acetate. Generated polymer particle size also changes the agitation speed as the heat released during the polymerization is absorbed by the surrounding solvent. Sensitively, the heating does not happen and it is easy to adjust the temperature. Suspension polymerization mostly commonly used as industry manufacturing method in order to get polymers for forming materials such as polystyrene, polymethyl methacrylate, polyvinyl acetate and polyvinyl chloride. Because a polymer with a high degree of polymerization is obtained with the polymerization, and generated polymer isolated is easy. And these are the advantages and disadvantages of the suspension polymerization. The process is comparatively cheap as it is involves only water instead of solvent. Actually, comparing to the solution technique, this suspension technique is cheaper since they are using water instead of solvents, where the solution technique using a costly solvent, and the viscosity increases is negligible. Temperature control is easy. Producing isolation is easy since the product is insoluble in water. And these are the disadvantages of the suspension polymerization technique. The method can be adopted only for water insoluble monomers. It is difficult to control polymer size, and polymer purity is low due to the presence of suspending and stabilizing additives. Larger volume of reactor is taken up by the water. Suspension polymerization reaction is a highly agitation sensitive. And this is fourth and last type of emulsion polymerization technique. This technique is used to production of large number of commercial plastics and elastomers. The system consists of water insoluble monomers. The monomers is depressed in a aqueous phase, not decreased the droplets, but in a uniform emission. The size of the monomer droplet will be around 0.5 to 10 m in diameter, depending upon the polymerization temperature, rate of agitation. The emulsion is dissolved in a water, and water insoluble or poorly water soluble monomers is added in it. It is a method performing polymerization by using soluble initiator. In the water solution, when the water solution of emulsion above the specified levels, emulsion molecules associate to the to form a micelle. Emulsion is comprised of hydrophilic and hydrophobic, and associated with the hydrophilic for exterior. In other words, water phase. If a monomer is added into an aqueous solution in which the emulsion forms micelles, since a monomer in water insoluble, it is taken in part into a micelle and exists in a droplet. As shown, the monomer droplet consists of emulsion molecules, which micelle formation. In addition to the initiator molecule, the polymerization takes place. This emulsion polymerization consists of three major parts: water and monomer and emulsion. Immersion and polymerization initiator used with immersion polymerization is water soluble and starts polymerization as generated radical in water phase reaches monomers. These are some advantages and disadvantages of this immersion type. Advantages are like high molecular weight polymers, fast polymerization rate, allows removal of heat from system, viscosity remains close to that of water and it is not dependent of molecular weight. The final product can be used as such. It does not reach any process or altered. And disadvantage of this process is like immersion and polymerization adjustment difficult to remove, and for dry polymers water removal is an energy intensive process designed to operate at a high conversion of monomers to polymers. Cannot be used for condensation, ionic or Ringler-Natta polymerizations. Actually, the emission polymerization is totally different from bulk polymerization and suspension polymerization used in other radical polymerization. In this point, the radical responsible for the polymerization is only one in a micelle, or the polymerization does not stop until the next radical enters into a micelle from water phase. Moreover, if the monomer in micelle is consumed, monomer will be reinforced from underwater monomer droplets and polymerization will contain advising. Therefore, the polymer with a high degree of polymerization is obtained rather than the obtained by the bulk polymerization or suspension polymerization, as the heat released by the polymerization is absorbed by the water around the micelle in immersion polymerization. So it is easy to adjust the temperature like suspension polymerization. Generated polymer obtained in immersion polymerization is used for various purposes such as paint, textile treating agent and adhesive without any change. Although salts are added, it can condense the solidify and the polymer can also be produced commercially. And these are the polymers which can produced by the different polymer techniques, where like polyamides, polycarbonates and polyethylene can be produced by the bulk polymerization technique, and low density and high density polyethylene can form by solution polymerization technique, and also nylon 6 can be generated produced by the bulk polymerization technique, and polyvinyl acetate can be produced by the immersion polymerization technique. Hence I discussed about the 4 different types of commonly used types of polymerization techniques which used to produce the polymers like polyamides, carbonates, polyethylene, polyvinyl chloride, polyacetate, like so on, which these polymers are used to produce a model using the additive manufacturing or rapid prototyping. Thank you for listening to my lecture.